19, deserts. Distribution and causes of dry lands. What is meant by dry? A dry climate is one where yearly precipitation is not as great as the potential for evaporation. Dry regions cover 30% of Earth's land surface. Two water-deficient climate types are commonly recognized. Desert or arid regions are more dry than steppe or semi-arid regions. So here, the yellow areas are deserts or arid regions, Sahara, Arabian, Gobi Desert, here's some examples. And then gray with our steppe or semi-arid regions. They tend to be around the arid regions. Subtropical deserts and steppes. They lie between the tropics of Cancer and Capricorn. The base cause, regions of high pressure, sinking air that's compressed and warmed. Few chances for cloud formation and precipitation. Okay, so here we have along the equator we have rising warm air, and it rises pretty high, then it starts to cloud up and drops its precipitation, and then it sinks. Now it's already dried out, and it sinks right about 30 degrees latitude in subtropics, north and south, and those are the zones where we'll find most of our arid or desert regions. West Coast subtropical deserts, cold ocean current cools air and prevents it from rising. Few chances for cloud formation and precipitation, often foggy areas. Say Atacama Desert as an example. Middle latitude deserts and steppes, sheltered in deep interiors of large land masses, far removed from ocean moisture. Also mountain barriers. As air rises over a mountain, clouds form, releasing precipitation on the windward side of the mountain. Air flowing over to the leeward side of the mountain is dry and forms a rain shadow desert. So here's our example with air coming off the ocean, nice and moist. It's going to rise up the windward side of the mountain, form clouds as it cools and precipitates. Time it gets to the top and starts to sink again, it's dry air. And so this side, there's no moisture to precipitate on the leeward side of the mountains, forming a rain shadow desert. So one side might be lush, and the other side very arid. Weathering. Okay. Well, geological processes in arid climates. One is weathering. Mechanical weathering is more prominent than in humid regions. Some chemical weathering does occur over long spans of time, which produces clay, thin soils, and oxidation of iron-rich sediments. The role of water. Most stream beds are dry most of the time. Ephemeral streams only carry water in response to specific periods of rainfall. When rain falls, most of it flows as runoff into the stream beds. And so here is a dry stream bed, an ephemeral stream. Then after heavy rainfall, then you have our nice filled stream channel. The role of water. Different names are used for ephemeral streams in various regions. Wash and Arroyo is western United States, Wadis in Arabia, North Africa, Dongas in South America, and Noah in India. The Wadi in its usual dry state. Okay, following a rainy period, it's all wet and vegetation sprouts very rapidly. Reading it up. Some permanent streams do cross arid regions, originate outside the desert and well-watered mountains, must contain enough water to compensate for loss from evaporation in an arid region. For example, the Colorado River and the Nile rivers do this. While infrequent, running water does most of the erosional work in deserts. So running water is very important. It'll carve the landscape when there is running water. Arid regions typically have interior drainage because the intermittent streams do not flow to the ocean. Erosion occurs without reference to the ocean. Landscape evolution. There's uplift of mountains, then running water erodes and transports materials into the basin. So here we have like our basin range, so we're alternating horsts and grabens, ridges and troughs of the mountain range here. So and when it rains, erosion is going to occur, bringing sediment into alluvial fans. Okay. And then here we have more erosion. Our alluvial fans are going to start to coalesce to form bajadas. And then we have our playa lakes may evaporate away, leaving playas as salt splats. And then eventually the mountains are worn away, and little remnants are going to be called, the original mountains are called inselbergs. So sediment-laden rivers form sporadic rain deposit debris at the mouth of a canyon. This fan-shaped sediment deposit is called a alluvial fan. The coarsest material is deposited first. A bajada forms from coalescing of multiple fans. So here's a bajada. So it's several alluvial fans that form one large fan. During heavy rainfall, streams flow across the bajada to form a shallow, short-lived playa lake. The dry, flat lake bed left after the water evaporates is called playa. Continued erosion diminishes the mountains to a few isolated bedrock knobs called inselbergs. So here's the playa in Death Valley. This differs. Transportation of sediment by wind. This differs from that of running water in two ways. One, wind is less capable of picking up and transporting coarse materials, and two, wind is not confined to channels and can spread sediment over large areas. The bed load is carried by the wind close to the surface, consists mostly of sand grains. Sand moves across the surface in a process called saltation by bumping and skipping. The height of the bed load rarely exceeds 1 meter above the surface. So here's saltation of sand grains that's being blown across the top of the dune. Suspended load is carried high into the atmosphere, consists mostly of silt-sized particles. Surface area must be high compared to its weight. Hard to move fine particles unless they have been disturbed on the surface. So a clay road with and without a car driving over it. So with a car driving over, it's going to be picking up the sand silts, and the silts and then are going to get picked up into the air. The suspended load can be transported far distances. Dust from the Sahara can reach the Caribbean. So here's a dust storm, blackens Colorado sky in the Dust Bowl in the 1930s. So this dust can move quite far. Okay, so here's the Sahara Desert here, Saudi Arabia here. That dust can actually be traveled by wind across the Red Sea. Paired with glaciers and running water, wind is an insignificant erosional agent. It's more effective in arid regions. Dryness and scant vegetation are important for wind to be effective at eroding. For example, the Dust Bowl in the 1930s. Deflation and blowouts. Deflation is a lifting and removal of loose material. Hard to notice because the entire surface is being lowered. During the Dust Bowl, vast areas were lowered by 1 meter in just a few years. Deflation also produces blowouts, shallow depressions. These can range from small dimples to depressions that are 50 meters deep and several kilometers across. So here's a picture of a blowout. So the vegetation is holding sand in place, but the sand around is being blown out, making depression. Desert pavement. Many deserts have a veneer of pebbles and cobble called desert pavement. Forms for initial surface of coarse pebbles. Fine wind-blown grains are trapped between the pebbles. Gravity and infiltrating rainwater move the fine sediments beneath the cobbles. So here, deflation is beginning as the wind is blowing the sand away. All the cobbles are just remaining, and so they kind of aggregate and form this pavement surface. And eventually, all the sediments been blown away, and then as more wind comes by, silt starts being deposited, and that falls under, sifts through the pebbles and raises the desert pavement bed. Ventrifacts and yardangs. Wind also erodes by abrasion, scraping. Wind-blown sand cuts and polishes rock surfaces, creates interesting shaped stones called ventrifacts. Wind also creates streamlined landforms oriented parallel to prevailing wind direction called yardangs. Okay, ventrifacts are stones that are shaped and polished by sandblasting. Yardangs are usually small wind-sculpted landforms that are aligned parallel with the wind. Two types of depositional landforms are created by wind. Dunes, mounds and ridges of sand from the wind's bed load, and loess, extensive blankets of silt once carried in suspension. Sand will accumulate wherever an obstruction blocks the wind flow, creating a dune. Dunes often form around a clump of vegetation or rocks. Most dunes have an asymmetrical profile. The windward slope is gently inclined, and the steeper leeward slope is called the slip face. The slip face typically maintains an angle of 34 degrees, which is the angle of repose for sand. Okay, so here's some there's White Sands National Monument, and the wind's coming at us. Okay, so right in front of us are the slip faces of these dunes. Sand deposits. The sand is deposited on a slip face, layers form, inclining to prevailing wind direction, creating cross-bedding. Moving sand can be troublesome for permanent structures like roads and buildings. Okay, so these dunes, here's our prevailing wind pattern. And as the sand's being deposited over the edge, it's going to form this layering, so these nice beds. And as these dunes travel and overlap, you form cross-bedding. Then the prevailing wind direction changes. Well, then the angle is going to change that the sediment's being deposited at. Types of sand dunes. Sand dunes are classified in 6 basic types based on their size and shape. Barken dunes are solitary sand dunes shaped like crescents, formed where sand supplies are limited and the surface is flat, hard, and lacking vegetation. So here is a Barken dune. Okay, the wind is going this way. The legs are pointing the other way. These are transverse dunes, perpendicular to the direction of wind flow. Barkenoid or scalloped, perpendicular to the direction of wind flow. Longitudinal ones are form parallel to the wind. And parabolic, the legs are pointing into the wind. And the star dunes are where winds come from many different directions and no particular prevailing wind direction. So as transverse dunes again are a series of long ridges oriented at right angles to prevailing winds, from where sand is plentiful and vegetation is sparse. Most coastal beach dunes are transverse dunes. Arachnoid dunes are an intermediate form of dune between Barken and transverse dunes. Longitudinal dunes form parallel to prevailing winds where sand supplies are moderate. Parabolic dunes form where vegetation partially covers the sand. And star dunes are isolated hills of sand developed where wind directions are variable. Lists is materials deposited by storms over thousands of years. Sources of sediment come from deserts and glacial outwash deposits. Lists in China originates from desert basins in Central Asia. Lists in the United States and Europe is product of glacial material. Lists, so here's vertical bluff, Mississippi River, 3 meters high. I have lists. These are very, we have sufficient structural strength from excavation of cave-like dwellings, but this is made of silt and smaller sized particles. End of the chapter.